Welcome to Talking South, episode 4 with Torsten Vidal and
Jennifer Hynes as our special guest from all the way from Boulder, Colorado.
Yeah, and you are in Greenland. How do you say the city that you're living in? Is it Nuuk?
Nuuk, like Donald Trump's favorite weapon, you know.
Oh,
So
God.
it's so good to see you, Jennifer.
It's good to
how are
see
you
you
today?
too. I'm doing good. Thank you. I'm doing really good. It's good to be here. Good to be here. There's so much going on, and you know, with all these things unwinding with abrupt climate change and this excessive ice melt in Greenland, it's really good to talk to you today.
Yeah, and you always wanted to be on Talking South, right?
I always wanted to be on Talking South, of course.
So how are you feeling about this new climate report and the IPCC UN stuff? It's been sort of going on and on and on for 2 weeks.
Yeah. Well, I mean, I'm glad that they put it out. This is the most honest they've been. I do believe that it's still way too conservative, but it's strong enough that it caught people's attention. For example, I was talking to my folks and my stepmother said, "Oh, and did you hear about this new report? You know, we have until 2030. And so whatever it is, it's strong enough that people, normal people out there in the world are taking notice of it. And I think, you know, although it's way too conservative, and I ultimately think that we already have fallen off the cliff to a large extent. At least it's an attempt at honesty. What do you think?
Yeah, I've been thinking and blogging and video blogging a lot about it, but after all of that, so the reflection comes in, and so I've kind of gone back to previous IPCC reports in my memories.
Yeah.
And it's actually quite interesting because I found out that it was the 5th IPCC report, the one just before this one. That was in 2014. And when I was reading that, that's sort of when it dawned on me that we had a sense of abrupt climate change that was not in the report. So I read that report with my background as an eco-activist and everything since the 1980s. And then I found out that, oh, this is horrible because they are actually holding back on the feedbacks. They are not talking about the feedbacks and forest fires in the Siberia and in the Amazon and all of these things that are feedbacks that are documented by scientists. Those feedbacks are not, and you are an expert in one of the largest feedbacks, which is the carbon feedback in the Arctic.
Yeah. I mean, that's been my area of focus for sure, but there are feedbacks all over the climate system, and the Arctic is related to everything else. But because it is such, I mean, as goes the Arctic, so goes the world, right?
Yeah, and I also think I heard just the last year, I heard that 3 big systems have started emitting carbon instead of soaking it up. It's the ocean, and it's the forest, and it's the soil itself. So all of those sinks used to be called sinks because they could draw carbon out of the air. Those have more or less started doing the opposite and giving the carbon back to the atmosphere.
Yeah.
And that's together with everything else going on in the Arctic. So it's
from sinks to source. I mean, it's all over the place, and we're kind of getting to the end of this end game, and it's so odd because it's still so hidden, but you can feel it. I don't know how much time we have left in the Arctic, but I do know that that's the only thing that's keeping our weather systems intact, and let's not mention the vast stores of methane that are deposited.
No, not on this show. This is a family show. So
Oh, okay, right.
No feedback.
We won't talk about these things. Pretend like they don't exist.
I'm just kidding. But I remember you said on a show a couple of years ago that you said it's gonna play out and we're gonna watch it play out. And so that's kind of one of the very strange things about living in 2018. That we have all the technical means there to watch things play out in real time.
We do, as long as, you know, these sources of data keep intact. I mean, we've seen some sources go missing from time to time. I don't know if have we lost any data sources completely at this point, or anything from like NASA, Earth Sciences? Have any of those data sources gone offline?
There is one source, because, you know, deniers often talk about the Greenland ice sheet. And there's a reason they talk about this particularly now, because for 2.5 years, the satellite has been down or you know, gone wrong or lost signal or something. So we actually have no data about the ice mass in Greenland at the moment. So that's why they try to fill that gap with deniers and say that it's increasing because we don't have the data that shows either way. You know?
Yeah, it's pretty scary. I mean, the level of just like truth is lies and lies is truth. It's just so like confusing to me. I mean, I almost have like PTSD from the level of deceit. I really do.
Yeah. And you know, the P in PTSD can also mean pre.
Oh yeah, for sure. Pre not post. I mean, it's, you know, or during, you know, whatever. It's like, it's very weird. I just feel that the world is going more and more off the rails, and we're almost entering into some sort of, you know, complicit insanity. It's bizarre, right?
Absolutely. It's like turning on the mainstream news is just like you feel just totally out of it, I think, if you know about some very, very specific, very dangerous threat.
Well, they have to keep the charade. They have to keep the charade going at this point because of their priorities, and rather than try and have a softer landing, I mean, rather than, you can either smash into the wall at, you know, 250 kilometers an hour, right? That's one style. You can do that. Or you can see the wall coming and you know you're going to smash into it, but maybe by the time you smash into it, you've gotten your speed down to maybe 20 kilometers an hour, or you've tried to do something so you don't have an absolute catastrophe when this hits, because that's unfortunately the vision that I see a little bit, and I hope I'm not like too doomy about it, but it just feels. Talking
about that, you are kind of the Rachel Carson of the 2000s, because you know, she wrote the Silent Spring, and you made two very, very influential documentaries about methane release in the Arctic. Talk a bit about that.
Yeah, well, P.S. if you want to host the demise of the Arctic on your site, I have a kind of funny story. So, you know, Methane Monster 2, the demise of the Arctic, the mere 2 hour and 40 minute, whatever, I don't know what got into me, but whatever, it did. That thing's been removed, so like you can go and search.
It's been pulled from YouTube?
Gone. It's totally gone.
Wow.
Like it's hardly, only a couple of people who actually copied it off. So if you, I have the source for it. I've got a copy of it. If you'd like to host it and be the new host of Methane Monster 2, I'll send it over to you, and you can give it a good replay. Methane Monster 2, but it might be time for Methane Monster 3. I mean, we're kind of getting to that point in life, don't you think?
I think we need a new methane monster every week or every month, because it's
Well,
getting very close.
yeah, it is. And I've actually, you know, we can whenever you're feeling like it, but I actually just put together a presentation for you just today, and it's,
Fantastic.
well, you know, old habits die hard. I mean, it's therapy. You know, we all have our different ways of doing therapy, right? And there's a compulsion, like those of us who have entered into the doomosphere at some point, you know, and that we've gone in for some reason, God knows why, into, you know, kind of like video activism, which is what I kind of, this is like video information activism or something like that. You know, it's, we are doing our bit to try and sway the consciousness at large. I mean, that's kind of a, that's sort of a ballsy thing to do, right? And it's like not that small, right? So, you know, we're working on things like that. And so, you know, when I get inspired, I just like, so what I've done here for you today is I've just created a little something for you.
Can we watch it now?
Would you like to? Let me
Yes, please.
see. All right, let's see. Let's do this thing. And I made even a little cover slide for you. Let's do this whole thing. So we're just going to call this, for all practical purposes, we'll call this Methane Monster 3. How's that? We'll just
Oh
make
my
it right.
God.
We'll just make it right now. It's
And
called
you saw
Talking
it here
South.
first. And you saw it here first on Talking South.
This is it. And I just made this presentation today. So we're playing this on Talking South, but we're really going to call this Methane Monster 3. And it is a little nerdy, and it does have a lot of, oh, wait a minute. Hang on just a second. There's one thing I forgot to do. Just give me a second and let me go back out of this thing, because one thing I neglected to do, which is very critical, is to share my screen. So I got so excited I didn't share my screen. So we'll start that little bit here. So share, here we go. Share this.
Sharing is caring.
Sharing is caring. Sharing is caring. So here we go, guys. So for all practical purposes, because I've been putting off Methane Monster 3 for so long, and I just can't seem to get enough energy or wherewithal to put it together, I just put it together today, and it's only like 30 slides, but we're going to go through it. There's just been so much stuff going on in the news. So anyway, let's go ahead. And why are we doing this, right? So this is the issue. The issue, I mean, there are many issues going on right now, but the main issue is climate and people's lack of ability to contend with this issue. They just cannot look at it directly. And it is the biggest issue that we've ever faced as a species. And because of our mental state as a culture in general, and the way our cultures run, we're not able to contend with this. And consequently, there's not really anything on the media really about it, except every so often. So we're going to attempt to take a look at this. But as we said earlier, the UN's devastating climate change report was too optimistic. So, you know, it is very good that they've put it out. It's a huge step in the right direction. It's almost like they're sort of prompting the thought of what's going on. So anyway, really, the story from my point of view is the Arctic, and we are seeing Arctic anomalies that is leaving. So this is an Arctic, this is actually a world map. It looks just like, you know, the Western Hemisphere mostly. And it's an anomaly, temperature anomaly map. And you can see, like, so I live in Colorado, you see like, here it's like super cold. The Arctic air mass has kind of slipped off, and replacing it is abnormally hot temperatures. So you can see these abnormally hot temperatures, and this was from October 14th, are affecting the Arctic at large, and they were abnormally hot in the eastern part of Greenland. I think that part of Greenland's actually experiencing some pretty serious melt, as well as over in Scandinavia with Norway and Sweden and so forth. So you've seen like people say the Arctic is getting hot 4 times faster. Yes, it is, but it's really, this is a very good pictorial, and masses can slip, so it's been really chilly where I'm living. So anyway, there you go. So before we dive in, let's just take a quick review of Arctic temperatures, and you know what the deal is with the Arctic temperatures. This is a graphic from 1900 to 2020, you know, current day really, 2018, from various measurements. So you can see it doesn't really come from one data source. We have 5 different data sources that are graphed, and they go roughly along the exact same story. So, you know, this is what's happening. You can see it, and the Arctic is rising quickly. In fact, you can see the Arctic's risen about 3 degrees Celsius, and it is rising more quickly in temperature than pretty much any place in the world. Now, this is a little bit of a drill down of that same map, and if you look at 1960 to 2018 present, you can see that the Arctic temperatures are going pretty steadily straight up. So that's kind of the story of where we go. But you know, heat plus ice equals less ice and water, you know. So what we see with both sea ice extent and sea ice volume is that they are decreasing at the same rate that you see the Arctic heating. It's not like rocket science, right? I mean, that's just the way it is. So that's chemistry for you right there. So if anybody tells you otherwise, go for graphs. The Arctic is a fascinating place. This is a really good drill down of the Arctic, and the area of most concern is this red area that's circled right here. This is the East Siberian Sea, the Chukchi Sea, the Laptev Sea. This is all that area around Siberia, the Yamal Peninsula, and all that area in the Kara Sea. There's huge, huge, giant stores of methane there. And you can see that this area is fairly flat. It is also fairly shallow. So consequently, when the methane, which is deposited, there's like huge, giant organic reserves that have turned into a pure distillate of methane, you know, the finest whiskey on the planet. I mean, it's white, it's pure, it's flammable, it's very potent, it's an energy source. Some people want to mine it, lots of corporations want to mine it. And since it's deposited in the East Siberian Sea, which is very shallow and very flat, and recently submerged as of the last ice age, PS, it doesn't really absorb much in the water column, and that means the depth of the water in the water column itself. Most of it will just escape directly to the atmosphere, and this is of great consequence because methane's a highly potent greenhouse gas. I know this is a review for most people, but it's a serious matter. So that's just a nice pictorial, so you can see the graphic of the Arctic. And the biomass is something that has to do with Arctic sea ice volume in this case. And what we can see is that over time, 2018 being in red, so if you want to trace 2018, it's this line right here. So over time, and this is a year, right? So this is from January to December, 1 year time. The Arctic sea ice volume is going down. Now we are in about the 4th lowest Arctic sea ice volume biomass measurement right now. But the thing that really is of consequence here is the trend, right? I mean, 4th, 5th, 1st. It's the overall irrevocable trend, and that's kind of where we're working, kind of talking about here. This is the sea ice volume again, just to kind of give you an idea of how we're doing for 2018. And, you know, I mean, it's still hanging in there, and that's hopeful. We don't want the Arctic sea ice to go away. I mean, we can see that the sea ice volume, if you look at it from like 1980 to the present day, the sea ice volume is going down. I mean, look at that. It's not really going down exponentially. it's going down in a fairly level fashion. But you just follow any line. I mean, you follow that line down, and where it hits the bottom there's no more ice. So it's kind of something to notice. The overall land ice in Antarctica and Greenland is also going down as well. It looks like in Greenland we're on a very, very steep decline. I think most of the sea level rise that we're experiencing on the planet really does come from Greenland ice melt at this time, but Torsten can fill us in. But Antarctica is going to take off and contribute a lot more exponentially over time. But right now, Antarctica, it is melting, but it hasn't like totally taken off. Greenland is really starting to take off. And sea ice is totally important. The buffer, the sea ice provides a buffer. It keeps this ocean up in the Arctic at about 32 degrees Fahrenheit or 0 degrees Celsius. And the reason it's able to stay at that kind of constant temperature even in summertime is it's got that buffer of sea ice, and all the energy is going into melting the sea ice itself. But once that buffer is gone, all those methane hydrates, which are frozen, and they also have the same freeze point and unfreeze point as regular ice because it's methane encased in ice. So they're going to start coming out. So this is kind of like a pictorial of the buffer that we were just talking about. And you can see it gets up right to 0 degrees Celsius, and then it just really doesn't go much above it. And then it just kind of, falls back down when it becomes the winter again. So, that's kind of what's been saving us. But this is a low sea ice extent that we had from 2018. Our low sea ice extent was on September 16th. And the fracturing, let me just kind of orient you in case you can't see it all, but basically Greenland is always super easy to pick out, right? And here's the Canadian archipelago, right? And then we come along and here's Alaska, right? See Alaska? And then we go across and that's the beginning of Siberia. And Siberia kind of snakes around to the Laptev Sea, that's the Lena River Delta right there. And then here's the Yamal Peninsula where everything's been blowing up. It's not really funny. Methane holes like craters exploded out of the earth. And then the Kara Sea, and then down into Scandinavia. So that's just your orientation. So, coming in through here with Alaska and right in between Alaska and Siberia, there's been a lot of hot action, and there's been melting that's gone, of course, all the way, it's pulled away from the East Siberian Sea a long time ago, but this melting this year went all the way to the North Pole, and the ice was fractured all the way up until the North Pole. And as well, the ice just north of Greenland and in the Canadian archipelago, that also melted. And people had thought, well, this ice on the north of Greenland is like so sturdy, it's never ever going to melt, right? So, but it did. So, it's not that sturdy when it gets hot. So that's just kind of an orientation of what's been going on. And what's really been notable, we've seen a lot of melting in Greenland over the past like 5 to 6 years, but lately they've been making new discoveries as to the nature of some of the ice cap in Greenland. And the Greenland ice sheet has been hiding a surprising amount of liquid water, and it's gotten to have pretty big reservoirs of liquid water that don't always refreeze. And then if they do refreeze, it's not like as strong as it was, So it's getting kind of like, I call it Swiss cheese on ice. So I think the Greenland ice sheet, it's full of moulins, of course, those drain holes that are all through it, and that's kind of Swiss cheese. And then you've got like these big cavities and reservoirs of liquid water throughout Greenland. And it's a significant amount of water. I'm not entirely sure on what the equivalent sea level rise would be if this water started leaking out, but I mean, it's only a matter of time before these types of reservoirs get dumped right into the North Atlantic. So let's see, The Arctic ice cover has lost about 2/3 of its thickness, and the older ice has shrunk by about 2 million square kilometers. So the ice is gone. I mean, it's a lot of ice that has melted, and it's just getting very fractured and messed up. And this is kind of interesting. So in the middle of the Arctic Ocean, there's the Beaufort Gyre, is what I believe it's called. And the Beaufort Gyre rotates, and it's been rotating faster and faster. And the nature of the gyre is drawing Arctic rivers into its center. And so the gyre has a lot of fresh water embedded into its center, kind of like a funnel, because it's spinning, and that action is drawing the water, because when the rivers come off, that it just kind of floats across and it hits the gyre and it gets drawn in. So this thing is spinning more and more, and it's got sort of a levee around it, and they think that at some point just the force of so much fresh water in the middle of it is going to break this levee, and this vast amount of fresh cold water is going to spill out of the Beaufort Gyre into the North Atlantic. I don't know if you've ever heard about that yet,
Yeah.
Torsten.
I think it's already started. It's already started to empty. Yeah.
Yeah, so that gyre is like right here, and it does it go counterclockwise or clockwise? I can't remember.
No, it usually goes clockwise.
Does it go clockwise? So the gyre is here. Right. Yeah. So the gyre is here, and it's going around and around. And so there are rivers all around here, especially like there's the Lena River here, and there's a bunch of other rivers in Siberia. There's the Mackenzie River, and then there's other rivers that dump fresh water right into the Arctic. Actually, the Arctic isn't very salty due to this sort of action, but right in the gyre, it's really fresh. And the Laptev Sea is interesting because it is a huge source of methane hydrates, and it is an area that has seen very high methane readings in the atmosphere as well. So, with all this heat that's going on in the Arctic is greening up. And what they're finding are these things called taliks. And I didn't know what a talik was, but a talik is unfrozen ground near permafrost that's caused by thermal or hydrological anomalies. So they become like these tunnels in the permafrost layers. And that is also another kind of Swiss cheese effect. You're just kind of seeing it's drilling down like that and making these tunnels. And they can get washed out too, so they can actually carry water and things like that. They're softer. So all of this is leading to a methane boost in the permafrost, and it will be around the Arctic Ocean as well, mostly in the Laptev Sea near Siberia. So I guess it's a good time to talk about the vulnerable carbon pools. Basically, these areas that are in brown are permafrost areas, and they're becoming permamush areas. A lot of this is a source of high methane, and you can see down here that they're talking about methane hydrates in the ocean as well. So, there are these stores. Lucky us. So as the Arctic Ocean is getting warmer, it's changing in its nature. As the ocean is getting warmer in the North Atlantic, because the Atlantic is getting really hot, and the North Atlantic, well, the Barents Sea doesn't really have sea ice anymore. So it's actually fair game for all sorts of plankton and things like that. So they're seeing now an invasion of plankton into the Arctic waters. And you can kind of look at this, it's got like little swirls and things like that as it kind of mimics the eddies and, you know, the little swirls that are naturally in the Arctic Ocean. But we're seeing a vast influx of plankton into the Arctic Ocean. So that's changing the nature of the Arctic Ocean. And this is actually more of a projection. So this hasn't happened yet, fortunately, but we are, let's say, we are right around here, but I actually think that we're higher. This one says, methane is measured, by the way, in parts per billion. You probably know that, but I think that we're higher. Are we at 1900 parts per billion right now? Do you know?
I think this is the global average, isn't it?
Mm-hmm.
So it's lower than the daily maximums.
Oh, right. You're right. So is this about right then? Are we about 1700 parts per billion globally?
Yeah, about 1800, 1850.
So we're on track. We're on schedule. Lucky us. Yeah, but methane is going up, and we will see methane increase over time. This is a more recent methane map. Let's see, this was from 2 days ago. Oh, yesterday. This is yesterday. So you can see any place that is pink is getting up there, and any place that is gray, it didn't get measured for some reason, and any place that is white is just a general blip in the satellite data due to the curvature of the Earth. But in any case, you know, pink is high, and you can see it's all through the mid-latitudes here until you get to the equator, where it gets broken down, because I believe there's a little bit more oxygen at the equator and it breaks it down, so it doesn't really cross over. It is a northern hemisphere phenomenon, as you can see. I mean, look at the southern hemisphere. As of yet, not much. Where's all our heat going? Primarily into the oceans. I believe about 97% of the heat goes into the oceans. Oh no, excuse me, 90% of the heat goes into the oceans. It is absorbed. So the ocean has been a carbon sink up until, I mean, it's still a carbon sink, but it won't absorb an infinite amount of carbon dioxide and heat. It will buck back at some point and become more of a source of heat. And, you know, speaking of a source of heat, check out our little latest blister across the Pacific Ocean.
Oh my God.
Yeah, we're getting, yeah, El Nino. Well, we just finished our last El Nino, you know, Torsten, just a few years ago, 3 years ago, we finished our last El Nino. And it's starting again. And in conjunction with this El Nino, what do we have? We've got the hot blob. Do you recall the hot blob right under Alaska some years ago? Right, a couple of years ago. And then it dissipated.
I think the last time we had an El Nino, the hot blob was so vast outside of California that you almost couldn't see the El Nino signature. So.
Yeah, well, the El Nino is starting to form, and as you can see, it's hitting Peru comme d'habitude. So, you know, this big Kelvin wave is going up and down, and you can kind of seeing it as it surfaces. So the El Nino is starting to surface. This ocean heat is really still kind of mid-ocean, and it's starting to surface. So here, along here, it's already surfaced. So it's like a giant wave, a giant lava lamp blob, you know, string of heat coming up. So that's going to change our climate again, and we're going to get typical El Nino type climate events, you know. Another thing that's been interesting lately is that there's been a huge high pressure zone over the Arctic that's affected the jet stream, and also it's caused a sort of freaky fall in Alaska. And they've been waiting around for their first freeze and snow. And this is because of the messed up jet stream, which is blocking high pressure aloft centered over western Alaska and warmer than average water in the Bering Sea. So there you go. As we said, there's a great deal of heat going in here in the Bering Sea, and it hits the Arctic. So that's
almost,
happening. Yes.
almost seems like a self-reinforcing thing, because we know that it's been very, very warm in the Bering and the Chukchi. So maybe that makes the jet stream more likely to, bend in like this, because it's already open water and already warm.
Yeah. Yeah. Good point. Good point. Here's a picture of ocean temperature anomaly. Yellow is hot in this case, and you can see the hot blob and the signature of the hot blob right under Alaska and over by Vancouver. So getting hot there. So now we're going to talk about funny stuff, weird things that have to do with abrupt climate change. And I actually saw this cartoon the other day and it made me smile. I mean, this current like strange relationship with facts and science that's currently going on, especially in America, I must say. We call this section Facts Don't Matter. So I'm sorry, Jeannie, your answer was correct, but Kevin shouted his incorrect answer over yours. So he gets the points.
Of course.
There you go. Can you shout loud enough? So, here's something kind of interesting. A brief history of oil and humans. You kind of get the picture. Anyway, I don't know if it's going to be quite this dramatic, but we'll have to see how this thing rolls out. Anyway, we're living at a very interesting point in history, you must admit.
Absolutely. I remember when we learned about populations in biology, it was always those kinds of graphs going up like this and then just collapsing. And that's so it's like, then we're talking about mice and birds and foxes and everything. So it's like it does that for every population, and it's like there's no reason to believe that humans will go very slowly down when all the other graphs for other species are very steep.
Yeah, for sure. Things are exponential and the crash is exponential as well. It's very hard to understand it. It's very hard for us to wrap our heads around something like that hasn't happened yet, because it seems, how could that be? So it's something, you can either entertain or not, but it's a hard thing to get your head around. But just wait till you see all the strange things that are happening in the world, right, due to strange abrupt climate change events. So here's one. This happened the other day in China. You've heard the expression raining cats and dogs, but what about raining octopus and starfish? So this is a picture of a poor little octopus, a disabled octopus that's plastered against somebody's window in China because there was some sort of sea tornado that scooped up all these sea creatures and then it just freaking hurled it. And all these animals into the city. And there were like these sea creatures everywhere. So very sad. I know, it's very sad. Here's another weird fact. Climate change might double the cost of a good beer. So this actually happened due to wheat crop failure, due to inclement conditions, and more extreme droughts and heat waves will hit barley especially hard. So the cost of your downtown beer might double due to climate change. That's something I bet you haven't thought about.
So if you don't care about climate change before, you will start caring about it when you see the price of beer going up.
Right. Right. Okay, so this is a weird one. I call this one the attack of the zombie worms. So there are Siberian worms that were buried in the Arctic permafrost for 42,000 years. And they put them in petri dishes and the goddamn things came back to life. So now these 42,000-year-old Siberian permafrost worms are roundworms. They came back to life and they're living happily in petri dishes after 42,000 years. That's weird, right? Not normal. strange. Here's another fun thing. Higher global temperatures could melt ice sheets that store long buried bacteria, spreading disease and potentially causing new global pandemics, such as plague may return with a vengeance as the earth warms, a scientist warns. So it doesn't mean that we'll all die of plague. There are like inoculations, and if you get the plague, you can probably get some sort of cure. It's not meaning that we're all going to die of the bubonic plague. It's just the fact that bubonic, so it's not a scare tactic. It's really just more of information, because the bubonic plague could come back to life after 42,000 years. You know, maybe the worms have bubonic plague and they're living in I mean, who knows? Maybe not like that, but you know, still strange, right? Oh, and anthrax, right? There were like these reindeer up in Siberia that had been in the permafrost, and they got thawed out and they had died of anthrax, like I don't know when, like way before the last ice age. And I think some kids in Siberia got sick with anthrax. Did you hear about that, Torsten?
Some indigenous kids.
It's really strange, right? Yeah. So this is non-nice. This is sad. Humanity is cutting down the tree of life, warn scientists. So a lot of mammals are going extinct now. It's not just like, you know, the microscopic creatures or who knows kind of, you know, I don't know. It's actually mammals that are going extinct now. So more than 300 mammal species have been eradicated by human activities. That's very sad. You know, you think about it. Yeah. Look at this cute little guy too. You just want to take him home. He's so sweet. So, you know, I guess like, I don't mean to be so freaking depressing, but I do like to look at the truth. So this is a foe beyond any of you. And I do think that we are morally obligated to look at all kinds of solutions and mitigation plans of all sorts on all levels. But before we can do that, we have to understand that this is a really, really, really big thing that is happening right now, and that nobody can really talk about it because it's too depressing, and it is a really big thing. So I think the first thing is to just kind of like realize that it's happening, and not just like at the individual level, because I mean the people who know that this is happening on an individual level, I mean they're all about it. They're like, yes, this is happening, but the way our society is structured and the way the corporations control really our fate, it has to happen at a cultural level and a societal level. And I don't know how that happens, but I know it has to happen. So we either make it happen and, you know, wake up to what is happening and try and work creatively to mitigate these disasters, or we have a very, very unpleasant experience. So some interesting things have been happening lately. Just like 2 days ago, there were 3 6-point-something earthquakes on the Vancouver plate. And this is a very, very, very problematic plate. I think that's called the like San Juan, I don't remember that last name, Fuentes or something like that. But in any case, it's sort of a shard, right? So, you know, you've got a massive Pacific plate, and then you've got this crazy little shard that kind of encapsulates all around British Columbia and especially Vancouver Island. And then that kind of butts up the plate that hits the American continent at large. But there's this kind of shard. And Vancouver has been very well, they've had bad earthquakes in the past, and people have been very scared that they'll have bad earthquakes in Vancouver again due to the way this particular plate behaves and how they're kind of thinking about it. So wasn't a small earthquake, right? So this was a 6 point, I think the biggest was a 6.8, but it was a 6 point, all in one day, get this, a 6.8, a 6.6, and a 6.5, all in one day on this massive, strange shard of a continental plate right near there. So that's happening. And as we speak, at this moment, Willa is making landfall. So it's kind of a notable day. This is a Cat 3 right now, but it's just at this moment making landfall right north of Puerto Vallarta in Mexico, and it's carrying with it a tremendous amount of moisture, and this moisture is going to go up right the central part of Texas. Right here is Texas, right? So poor Austin.
Texas always gets it, doesn't it?
Yeah, you know, and I mean, they've already been saturated, so this is going to go and just create a huge, probably abrupt climate change rainfall event. I mean, it's carrying a lot of water with it, and it's got a long tail. So it was a Cat 4, it's now a Cat 3, so it's not so blowy, but it got a little bit bigger in the process, so we'll see. But anyway, that's happening. So, you know, there's a better picture of Willa and what she's up to, so that's happening right now. Oh, and then as a consequence of Hurricane Michael that we had 2 weeks ago, right, that hit Florida with such a vengeance and just took out that whole area right up in here. Poor Florida. I mean, they've got a huge, giant red tide algae bloom going on right now, and it's killing sea life. And this is really paradise lost. So more than 8,000 miles of Florida coast is now suffering from an unprecedented red tide algae bloom. So, you know, I mean, it probably washed, you know, when Hurricane Michael came in, I mean, how much water was contained in that hurricane, and it just, you know, and then all of those, like, you know, pig poop farms and I don't know. I mean, all this nasty stuff, whatever is part of civilization, it all just kind of got sucked into the water, and now they're having a nasty red algae bloom. Poor Florida. They've been having a hard time.
Yeah.
So anyway, another thing to consider as we kind of keep all these horrible ideas in our awareness, it's a lot to kind of take on board, isn't it? Is places, you know, in the future where water wars may be fought, because as climate change really sets in, water is going to become more scarce, and, you know, consequently, you know, population is going up. I mean, it doesn't look good. So, you know, just in case. Oh God, it's so horrible. So there's another thing too, and that's the problem of food, right? So there are places where there have been huge giant famines in the past, and this place notates historic famines that have happened in the past. And we've even had here in the United States Dust Bowl, but you know, there's been some major famines, but it hasn't really happened too much lately. But oh, here's the one that got rid of the Anasazis, I believe. In any case, you know, we'll probably have something like that again. I mean, if water becomes a problem, and for example, here in the U.S., we've got that, what is it called, Ogallala Reservoir or something. It's, you know, this fossil water, basically ancient water that we're just using as fast as we can for animal feed, it seems, mostly. Either that or ethanol. It's a great use of fossil water. Don't mind me, I'm dripping in sarcasm. But, you know, I mean, if you don't have water and the temperatures go up and you have a drought and it doesn't rain, and you plant like all your corn because you think it will rain and it doesn't, And then your fossil water dries up. So there you go. So net, climate change is even worse than we thought. So indeed, the IPCC report was way too conservative. However, they made a gesture in the right direction, and we in the Doomosphere deeply appreciate their gesture in the right direction. We understand why they can't go the full Monty. It is a very daring thing to do, and it would be out of character for the IPCC to go the full Monty. However, those of us here in the Doomosphere feel compelled for some unknown reason to go the full Monty, and so here we are. So climate change is bad. And we're also seeing changes in Antarctica. There are a lot of Arctic sea ice loss is being seen, especially, of course, in Western Antarctica and the Larsen Ice Shelf, and in this area especially. So over time, that's going to contribute more and more to sea level rise. The ice shelves themselves are starting to destabilize. You can see some of the bigger ice shelves in here, but there are ice shelves all along in here, and they're seeing some significant melt, even in the north and east of Antarctica. They're starting to see some significant melt up here, and the Totten Glacier over here on the east side is also starting to destabilize with, you know, a huge amount of seawater just being dragged into the Kashmal underneath because it's lower than sea level, the way that land is. So, you know, the Antarctic sea ice shelves are melting, and one of the stranger than expected, you know, this would go into stranger than previously expected category. I think we have to invent that now at this point. Stranger than previously expected, as well as, like, you know, ocean creatures being plastered on your wall. The Antarctic sea ice shelf is emitting a very strange noise as it melts, and they've been actually measuring this and listening to it with microphones, and you can hear it, and I've heard it myself, and it's eerie and it's strange and it's kind of sad. So that's happening. The Antarctic sea ice shelves are singing.
I've listened to a lot of sounds from the ice, both in Norway and here in Greenland. But is it something special that makes this?
Well, see, I don't know, Torsten. I couldn't possibly tell you. I'm a sea ice song virgin. This was my first sea ice song.
Okay.
So it may be normal, but if you never have heard it before, it's a very strange thing to hear the sea ice melting. And anyway, so that's the presentation I put together for you tonight. So
fantastic! That was way more than I expected.
There you go.
How to comment all of this? I would just start by saying thank you very much.
Absolutely. I'm trying to unshare here. Stop share. There you go. Hello.
Okay, we're back.
So for all practical purposes, we'll call that Methane Monster 3, even though we didn't really talk too much about methane. I mean, we can see, and I'll just give methane a little plug right now, because we referred to the methane as a potent greenhouse gas, and yes, indeed it is. But did you know that when methane is first emitted, it is 125 times stronger molecule for molecule for a short period of time rather than carbon dioxide? So there's that. There's also the fact that when methane is in its hydrate form and it's encased in its sea ice cage, it is compressed. It is small. The sea ice cage is strong, but it's made of ice. It's an ice crystal palace. And when this ice crystal palace you know, melts, right? It becomes large. So it goes from small to large to the tune of this is 1 and this is 164. So the ratio,
160.
yeah, so the ratio, so I mean, let's put a plug in for the Yamal Peninsula and the methane blowhole craters that are being seen there that are coming up in the Pingo formations. And why are these Pingos? It's like zits. It's a bad case of acne up in the Yamal Peninsula. And it's like, and the reindeer herders that are up there, they see these things when they go off in the night. You know, these things don't go off quietly. They go off with a bang and they burst out. They basically explode the heavy, but you know, it's like this very strong biologic crust kind of, you know, that's been developed, you know, that's there, and then the methane hydrates that are underneath are thawing and thawing and thawing, and like pressure and pressure and pressure, and it's just like, and then there's more heat and it goes more and more, and there's all of a sudden there's a little hill. They're like, oh, well, I wonder where that hill came from. It wasn't there before. And then it's like and it bursts out.
It's even fire in the night, I think.
Fire.
When they blow it, I can see fireballs.
Yeah, fire in the night.
But do you think you could walk us through just briefly, because we started off, or I anyway often start off talking about the ice that is on the top of the planet, and then how do you get from slightly less ice in the sea and to this methane bomb coming up from under the sea?
Yeah. Sure. Well, you know, the Arctic sea ice cover is vital to our life on Earth. That much is clear. When the sea ice is melted, the energy that goes into melting the sea ice from the warmer Arctic, and the warmer Arctic, you know, it's being warmed by coming in through the Barents Sea, through, you know, the Beaufort Sea, from all the rivers, from the ocean itself, and from the top. So it's being really attacked by all sides. And the ice is getting smaller and smaller and smaller. When the Arctic sea ice goes away, the Arctic sea ice will no longer remain at approximately 0 degrees during the summertime, right? I mean, it won't, because the ice will be gone, the buffer will be gone, and it will rapidly start to warm. Once that Arctic sea ice goes, there is no more buffer. And what you will find is that the Arctic Ocean is going to warm rapidly. When the Arctic Ocean warms rapidly, the methane deposits they're already starting to thaw, especially up in the Laptev Sea, the East Siberian Sea, the Lena River Delta is area of high methane, but these deposits are vast and they're large. You can't mine them all up. It's not a problem like that. It's much bigger. And so when the Arctic Ocean is free of ice, it will raise up in temperature very quickly, and the methane deposits that are all laced throughout, especially up in Siberia, will start to go off. And they're on land as well as sea. And this is a feedback, and this is a runaway feedback, and it's interlocked with many, many, many other feedbacks, climate and otherwise. But you'll just see permafrost turning to permamush. You'll see lakes showing up as the land caves in. You'll see the edges of land breaking off, and as the land breaks off, you will see it striped with the pure white methane hydrate that will go directly into the atmosphere. It's there, it's present, you know, it's not a matter of opinion, the vast stores of methane. So that is the danger with the Arctic sea ice melting, and that is why we say that the Arctic sea ice is absolutely a tipping point.
Yep, because you get more and more sunlight going into the shallow seas when there is no ice on top, and so then you warm up the whole column of water all the way down to the bottom of the shallow seas, and then you gradually thaw up the seabed, and then you get released methane. Okay, we're running up to the hour. Maybe we should, let people have a break.
It's been too nerdy, really. This is a lot of information. It's not nice, right? But we have to know about it. So it's been a real pleasure, Torsten. So thank you so much for inviting me on Talking South.
And I would very much like to have... Would very much like to have you back, like, say, in a month or two or whatever,
Sure.
when you feel like it.
Be happy to come in, and we can catch up on the latest developments and see what's up next month. It's fine.
And then we can scare the people who didn't get scared this time. We can scare them next time.
I know. It's not really what I had planned to be like this horrible fear-mongering person, but
it's good to know. It's better to know than to be left in the dark.
Yeah, it is what it is. But if you want to know, watch this show. If you don't want to know, turn on the TV. That's what I should say.
Yeah. Okay. Signing off. See you next week, Wednesday night. Bye, Jennifer.
Bye-bye. Thanks.